Hi, thanks for joining us today. Today we're going to be talking about lesson 9-6, which is a review of the basic integration formulas you've learned this year. It's not really that different from 9-5. If you've watched and mastered 9-5, if you've done all the homework, you really should be on a good pace. It really was similar to this lesson. This lesson will focus on some of the basic techniques as opposed to just applying the formula, but that was already present in 9-5. More practice, more practice, more practice. So, a summary of all the integration formulas you need to know is on page 211. You can see that you'll have a lot of help for the Unit 9 test. 211 is kind of an overwhelming amount of information, if you look at it all at once, but you kind of already know a lot of it. Every year, students ask me, Mr. Leven, will we get this on the AP test? The answer is absolutely not. You need to know how to do it. And it's a skill, and you've already kind of learned a lot of these skills. If you practice a little time every day, you're going to be fine on the AP test. If you're trying to cram it all, if you've been struggling with integration all year, and you try to cram it all the night before the AP test, it's not going to go well. Like any skill, you need to practice, practice, practice. So memorization alone will not be enough. That's a key idea. Integration is a lot harder than differentiation. Integration would be as easy if it was always one of the basic forms, but usually we have to mold our integrals to become one of the basic forms. So while differentiation is sort of a follow recipe, integration, some things even look similar. You have to make adjustments. That's going to be a key idea of today. So, success. You got to memorize all the formulas. You have to recognize which formula to be used. That's the hard one, I would say. That's the one that takes time to develop. That's the one you need to focus. If you're tutoring your friends or if you're getting tutored, if they just tell you which one it is, that's bad. And then the ability to use algebraic techniques. We all suck at algebra. I've said that enough this year. And or substitution to put problems into forms. And then lots of practice. So you can go back and do every single integration problem of the year. That'd be good practice. If you do every single integration problem in this lesson, the last lesson, 9-7, the next lesson, you're going to be a lot better. And we're going to keep practicing throughout April, and we're going to get good, and it's going to be great. Here we go. A lot of the video today is going to be, hey, you do it. Again, all four of these look similar. That's the idea. That's why they're called look-alike. You have to use 3 different formulas. Ooh. So some of them are actually the same. Try it out. Did you use 3 different formulas? Try it out again. You should realize you need 3 different formulas. That's the goal. Pause the video. Actually pause the video. 3. Did you try them all out? 2. Did you really pause it? 1. Here we go. So the number one I would check if it's a fraction, log. Log is the number one I check. So if the entire bottom was u, what's the derivative of the bottom? 2x. Is that on top? No. Can it be on top? No. So it's not log. If you did the first one with log, I don't know, punch yourself in the face, right? But no, if you did the first one with log, that's a bad sign. That means you're not really understanding how to check for log. Log needs to look like u under u prime. The derivative of the bottom is not on top. It can't be on top. It's not a log. Bad. So when we can't do log, I try to see if it's a sum of squares. Oh, it is. It is a sum of squares. What? So that's a squared plus u squared. A equals 1. U equals x. And then u prime would be 1. Can I get 1 on the top? You betcha. 1's already there. Again, if the dx is what bothers you, factor that out. I'm not going to waste my time rewriting each of them. I'll rewrite this one. You can write it as 1 over 1 plus x squared. You can blame everything on the dx. Get used to it. So this is arc 10. It actually should have been done right away. If you've learned your arctan stuff, you can write it as 1 over 1. You can write it as x over 1. Is that going to be necessary? No. Done. That's number 1 right there. You should have recognized that as a derivative. That'd be the best way to do it. You shouldn't have to check if it's natural log, to be honest. Next. All right, my favorite one. Let's check log. If that's u, what's u prime? 1. Oh, hooray, we can get it on top. So this is a u prime over u form. B is natural log 1 plus x. Now, at this point, I'll say, if you got the first 2 wrong, why don't you do the last 2? Seriously, go ahead, try it out. 3, 2, 1. You're just hurting your grade if you're not going to actually try it out, if you didn't actually pause it. I don't care if you're watching this at the last possible minute. All right, I check my favorite rule. I check making the entire bottom u. 1 plus x squared is u. What's the derivative of 1 plus x squared? Oh, 2x. So it's going to be a u prime over u form, but I need a 2 up top. So I would first rewrite this as 2x over 1 plus x squared. The x can be next to it or outside. It doesn't matter. That's the hook off. That's the u prime. And if you have trouble distinguishing your absolute value bars from your ones, put the flags and the base on the ones. One last shot. If you got all 3 wrong, try the last one. Retry it. We used log twice, so it's going to need a completely different one. 3, 2, 1. So the entire bottom is hard to make into a u. If you don't understand what I'm talking about, if the entire bottom was u, that's a much more complicated derivative. That would make u prime equal to 2. And you should already know that's not on top. That's what I'm saying. It's because the bottom, that bottom right there, is a group to a power. And I've been training you since December to recognize that. If you see a group to a power, you should try the what will a power rule. And that's the inside. And the derivative of the inside is the hook off, which is 1. I have 1. I always have 1. It's been there all along. Add 1 to the power. Keep the inside the same. Divide by the new power. It's not natural log just because now it's -1. That would be an acceptable answer. What else would be an acceptable answer? -1 over 1 plus x. Just because it looks like that doesn't mean it's natural log. That's not what happens. We just integrated. Each time I've gotten rid of the integral by actually changing the inside. Okay, I know power rule. They look similar. It's different. All right. Integrate each of these 2 lookalikes. Again, you will probably need a slightly different rule for each of them. These are harder than the last one. 3, 2, 1. Give yourself time. I don't know why I counted off. I got excited. Give yourself some time. If you're struggling, it's okay. 3, 2, 1. All right. So if you said the bottom was u, in this case especially, that would be problematic. If the bottom is u, if you really think that's an option, then we would have to use product rule. It's never going to be log if you have to do product rule on the bottom. Ever. It's never going to be log if it's a group rule on the bottom. Okay, so now we're saying, okay, it's not log. I'm sorry. It's not log. What else could it be? I don't know. I really don't know. What else could it possibly be? Well, if the entire bottom is not working yet, What if we just focused on rewriting it? What if we just wrote it as, well, I know natural log has a special relationship with 1 over x. Okay, I know natural log has a special relationship with 1 over x, right? Natural log's derivative is 1 over x. So let's separate out a 1 over x. And then we'd have 1 over natural log x. And then we'd have dx. Just kind of blowing apart all the pieces here. This is equal. I didn't make any hookups. I'm just separating things out. Like what? If you multiply this all together, you'll get this. That's how fraction multiplication works. Well, now, I don't know. It still feels like we should be using natural log in some way. So if I say this is 1 over u, okay, like the integral of 1 over u times u prime. So we're still saying it's u prime over u. Okay, these are the same thing. Both of these are natural logs, are natural log integrals. So now if this was u, then u prime would be 1 over x. So I have the hook off. So I'm doing integral of 1 over u times u prime, which is natural log, absolute value u. Okay, so u is natural log x. So here we go. This is the craziest one. I think this is the hardest one you ever encounter. Natural log absolute value, natural log x. There's no absolute value on the inside, plus c. It's natural log of natural log. This one's really confusing. You might want to rewatch this section. The key idea here was to separate it out so that way I could see natural log's derivative. Anytime you see natural log inside the integral, look for 1 over x. When you see okay, because that's u prime. Try to apply that device here. 3, 2, 1. Do you see do you see 1 over x here? I do. I would see it if I wrote it here, like just rewriting it as natural log x. You can write over 1. We don't really need to. It might help you see what's going on here. Now this is harder. This is definitely harder. This is one of the hardest ones in the book as well. If you're stuck, go ahead in the video. If not, go ahead, try it out. 3, 2, 1. The key is to notice that we could write this as a power. And that's a really hard move. Everyone should see it now. So this is the hook off. This is the derivative of the inside of the group. I keep the inside the same. I add 1 to the power. I divide by the new power. Done. Because I have the hook off right here. That's why we're going to look for 1 over x when you see natural log x. I really can't give you more advice than that. Here we go. So here are the simplest algebraic techniques we have. This is step 3 of getting good at integration. You can multiply things out, expand, like FOIL, basically. Term by term division, dividing by a monomial, one thing on the bottom. Okay. You could do long division, polynomial, when the degree of the numerator is bigger than or equal to the degree of the denominator. Or you could split. Now 2 and 4 are pretty similar. You'll see each of these 4 techniques on the next page. 9-7 is only going to get harder. Please make sure you understand what happens in these next few examples. Again, I'm going to keep saying it. Try this out. We're going to use these 4 techniques. Try them out. See if you can figure out which one's which. Please pause the video and try it out. 3, 2, 1. Let's say you thought this was reverse power rule. If that's u, the derivative of u would be, what's the derivative of e to the 2x? Be 2e to the 2x. The derivative of the exponent times this guy minus 0. Is that on the outside? No. Can you get it on the outside? No. That's a bad idea. So nothing else works here. That's why I know to try to expand it, to FOIL, to multiply it all out. So if you FOIL it correctly, you should get e to the 4x minus 4e to the 2x plus 4. And now each of these requires a different hookoff. So I'm actually going to do this as 3 separate integrals. I don't see enough people doing this. For instance, what I've seen people do is do like, oh, I need a 4, so I'll multiply by 1/4. Now that 1/4 is going to go on everybody. That's a really bad way to do it. So when you have a complicated inside, please make sure, and by bad way I mean you're going to get the wrong answer unless you cheat your work. If you have a complicated inside, write it as 3 separate integrals, please, for your grade, for my sake, for your sake, for everyone's sake. I can bring the 4 out. It's okay. You're really allowed to do that. You have the power now. Now, the integral of 4 dx is not a big deal, right? But we're going to treat it like it is. Okay, over here, I need a 4 on the inside. The derivative of the exponent is 4, so I need a 1/4. That works. Because now it's just 1/4 with this whole integral. So that's 1/4 e to the 4x. Because that's the hookoff. Okay, that's where that 4 goes. It's the hookoff. We put it there to die. Over here, what do I need? Well, the derivative of the exponent in here is a 2. That's the hookoff. It's there to die. So I need a 1/2. 4 times 1/2. Negative 4 times 1/2 is negative 2. Please make sure you're understanding what happened so far. The last thing that happened, integral of 4 is 4x plus c. If you have 1/4 times all that, it's wrong. If you got this by magic, it's wrong. I will mark it as wrong. My work is really the minimum of what I should be seeing from you. It's not hard to split it. It's not hard to squeeze in those hookoffs like I did. 4. Did you really try this one out yet? 3, 2, 1. It's not log. I hope to God you didn't write it was log. The calculus gods. The derivative of the bottom is not on the top. It's not anything else we've done. Well, what do I notice? We have one thing on the bottom. So I'm going to split it up. This will be one of the last times you ever see me write it like this. Appreciate it. We have this guy. We have this guy. I'm splitting over a denominator. I'm splitting over a denominator. And we have this guy. I'm going to write each of these as a separate integral because that's what's important anyway. X divided by root x. You can subtract the powers. You can come to any number of conclusions to get x to the 1/2. Root x, however you wrote it. Minus the integral of 2. Sorry, dx. I'm splitting up the integrals also because they probably will require different hookoffs. Not really in this case though. Plus the integral of x to the negative 1/2. Did you remember the negative? Did you even try it out? Did you pause it though? X to the 3/2 times 2/3. Add 1 to the power, multiply by the reciprocal. 2x, add 1 to the power, multiply by the reciprocal. These two need to be second nature to you. They really do. They're basic algebra. Next. Okay, more complicated. Try them both out. Guess which techniques they'll be. Hint, it shouldn't feel like a guess. 3, 2, really pause the video right now. Try it out. 1. Again, if you did this one as log, stop it. They're not all log. What's the derivative of the bottom? If this guy is u, if that's u prime would be 2x plus 1. Is that on the top? No, it's not log. Stop it. Okay, what do I notice though? What do I notice is that the degree of the bottom matches the degree of the top. So it's an improper fraction. So I'm going to long divide. Try out the long division yourself if you haven't already. Top dog in the doghouse. Shouldn't look like radical. Whatever. Top dog in the doghouse. I need to make the fronts match. Oh, look, they already do. I need a 1. 1 times all this garbage. And remember, we're subtracting the whole thing. So if I subtract this whole thing, x squared minus x squared, 0. Negative x minus x, negative 2x. Did you write 0 there? Tut, tut. It really makes it much harder. And then we want to bring down. We always want to carry down. Okay, so this is the denominator. I should have written that in a separate color. What's good? Blue. Is it good? I don't know. Looks too similar probably. So this whole integral here becomes the quotient, whatever, plus the remainder over the original denominator, the divisor, dx. Okay. Try this one out. Here, I'll even give you one for free. The integral 1 is just going to be x. How about this one? It's a little more complicated, but not improper anymore. 3, 2, 1. The first thing you should try, here's my hint, is thinking of it as a log. U and u prime. Well, the derivative of the bottom should be 2x plus 1. Oh no, but we have a negative 2x minus 1. So the key here is going to be factoring out a negative. Isn't that fancy? And again, now this is the whole hook off. It's u prime over u now. Done. Good? Bad? Again, one technique would just be to try these all again. Just do the homework is another option. You need to get better at it. Whoa, Nelly. Oh, I know what happened now. That should be locked. And I just want to shrink this a bit. Oh my God. So unprofessional. All right, this one. Now, whenever I see a root in the bottom, my two options are arcsine or power rule. Usually. Is it power rule? No. Because if it was power rule, we would look at the derivative of the inside of the root. Okay? And the derivative of the inside of the root is 2x, not on top. That should make sense. Okay? If it was power rule, we would do this. That whole thing needs to be in a group. Hint. And then if that's u prime is 2x. That's not here, and it's never going to be there. Stop hoping. If it were, it's not going to be natural log. Ooh, I hope you didn't think it was natural log. Okay, but then you may have said, oh, it's a squared. Oh, it's root a squared minus u squared. And then a equals 1. I mean, it's good if you can notice that because it's going to come up. It's the whole point of the last lesson. But that whole thing is not 1, and it's not going to be 1. So this is kind of the fourth technique, quote unquote. We saw this in the last lesson, actually. Just split it. And then I'll write it as dx. I'm splitting it, keeping the denominator the same and the numerator different. Minus the integral of x okay, like that. I'm actually going to move it so we have more space to work. Now each of these integrals is done a different way. The key idea is knowing to split it, which is hard, I admit. It's really that nothing else is working, so I'm going to try something algebraic. This one is Arcsine. Pause the video, try them out. I should have already said that. This one's Arcsine. 3, 2, 1. It's 3 times 1 over, okay, we want a 1. Now we can get it. Okay? Now this one's a little harder. Minus. I'll show my work here because we're going to manipulate the other ones, so why not, right? In case I don't want to be too mystifying. 3 times the integral 1 over. I'm just factoring out a 3 because of its arcsine. If it's a squared minus u squared, I want 1 to be my hook off. Okay? A root a squared minus u squared. I'll say it again. Now over here, again, when I see the x on top, it stops being arcsine. It stops likely being arcsine. It could still, much less likely. And it's definitely less likely if it's a squared minus u squared. Again, u would have to be x, so the u prime would have to be 1, and that's not going to be 1. So it's probably the power rule. When you have a square root on the bottom, it's power rule or arcsine, almost always. So we have x times 1 minus x squared, negative 1/2. You have the negative. And wouldn't you know it, I need it to be, I need it to be the derivative of the inside is negative 2. So we need a negative 1/2. Okay, I know that's ugly. That's a negative 1/2 and a negative 2 right there. So now we get, and again, you should really see this as the derivative of arcsine. That'll make you much faster. Negative of a negative is a positive. Again, that's the hook off. And then we're going to have add 1 to the power. Add 1 to the power. And multiply by the reciprocal of the power. Plus c. 1/2 times 2 is just 1. Be a nice clean integral. Okay? So I've alluded to this before. I've spoken to some of you about this privately already. We separated the numerator to create basic integration forms in example 6. This is not okay. And some people have been doing this all year. That's a no-no. You cannot separate a denominator. Stop doing that. How would you integrate this? 3, 2, 1. It's not natural log. If it was natural log, the derivative of the bottom would be 2x. That's not going to be on top. So what else do we have? Oh, a squared plus u squared. It's a sum of squares. It's arctan. It's the derivative of arctan. That's what you should recognize. Okay? Done. Next, last. Okay, try these two out. They're a little harder. You're warned. Try them both out though. They're not impossible. 3, 2, actually pause the video and try it out. I'm getting tired of saying it. You're getting tired of hearing it. 1. All right. I said this in class one day. You have two options here. Okay? Which hole can I jam this peg into? Is it going to be a trig integral or is it going to be a exponential integral? Well, if it was a trig integral, I would look for the derivative of the inside. 2. Is that going to be 2? No. Well, let's try something else. If it was exponential, I'd look for the derivative of the exponent. What's the derivative of cosine? Right? Like where it's e to the u. And u would be cosine. So what's the derivative? Not the integral. The derivative of cosine would be negative sine times 2. Okay, that's important, and the negative is important. So we need a negative sine 2x. Negative 2 sine 2x. Oh, look, we have a sine 2x right there. So it really is that simple. Hopefully that work can happen in your head eventually. So I need a negative 2 right there. So I'm going to pay for it with a negative 1/2. Like that. That whole thing is a hook off. Again, you need to make one of those things a hook off. You can't split it up over multiplication. You can't just integrate this and integrate that. If that's how you did it, that's really bad. Stop. That whole thing's a hook off. That's what takes care of the sign for me. Negative 1/2. And the exponential rule is the best rule. Just keep it the same. Done. Harder. Really try it out. Try a bunch of different things. Attack it from all angles. So one thing that helps you narrow things down is to see relationships. I'll talk about that in a second. Let's try log. Everyone always wants it to be log. This isn't log. Why? Because if this whole thing was u, what's the derivative of this? It's not secant squared. That guy's tan x squared plus 9. The derivative of this would be 2 times tan x to the first times secant x squared. Is that on top? No. That's the derivative of the entire bottom. So if it's supposed to look like u prime over u, it doesn't. It's not always log. So then I always get people using trig identities. That's not right either here. The best thing you can notice is not log. So what else do we try? Maybe it's, oh, it is a sum of squares. So it's u squared plus a squared. Well, I don't know. It seems like a long shot. Let's see what happens. That would be u would be tan x, a would be 3, and then u prime would be secant x squared. Wow. It's like it was designed to be done by us. So then it's 1 over a arctan u over a. Now, careful, don't cancel them out. Don't do anything smart or creative. Just, stop. It doesn't cancel the way you want. Okay, so that's it. Try out the problems. Good luck on the homework. Let me know if you have trouble. Talk to me in person. Email me. Good luck. Have fun. Congratulations for getting it this far. Thanks for watching. Have a nice night. Have a nice day.